This is section 2.4, the chain rule. So the chain rule is a rule that helps us find the derivative when there are functions inside of functions. So the derivative of f of g of x is f prime of g of x times the derivative of g. So don't get too caught up on that. It'll make more sense once you see examples. So finding the derivative of each using the chain rule. So let's look at the first one. So the first one, to find y prime, what you're going to do is you're going to do the derivative like normal. So I'm going to bring down that 3, rewrite what's on the inside, decrease the exponent by 1, and then we're just going to multiply by the derivative of the inside here. Sometimes it's called the inside-outside rule. Okay. And we can just say that's 6x times x squared plus 1 squared. You do not have to multiply that out to get your answer. So let's look at the second one, f of x. So we have f of x equals the cubed root of x squared minus 1 squared. Remember, we can rewrite that as x squared minus 1 to the 2/3. So to find f prime of x, we're going to do it exactly like we did in the last one. Bring down the 2/3, rewrite the inside, and subtract 1, so negative 1/3, and then multiply by the derivative of the inside, which is 2x. Remember, a negative exponent just means it goes in the denominator. So on the top, we're going to have 2 times 2x, which is 4x, over 3 times the cubed root of x squared minus 1. If you don't want to change that exponent of 1/3 to a cube root, that's fine. You could also have 4x over 3 times x squared minus 1 to the 1/3. Both are acceptable. And let's take a look at what it looks like inside of a trig function. So we have y equals cosine of 3x squared. So y prime, cosine goes to negative sign, so I'm going to do negative sine of 3x squared. But then we have to multiply by the derivative of 3x squared, which is just 6x. So I'm just going to rearrange it to be negative 6x sine of 3x squared. And then we're done. And for a longer one, you could go ahead and multiply this out since it's only a squared, but let's just leave it for right now so we can practice our chain rule. So f prime of x equals, we bring down the 2, and then 3x minus 1 over x squared plus 3, now to the first, and I'm going to need more room, times the derivative of the inside. So the derivative of the inside is low, d high, minus high, d low, all over low squared. All right, let's try to clean that up a little bit. So I'm going to distribute the 2 in to that first part. So it's 6x minus 2 over x squared plus 3 times, I'm going to keep this together, so we have 3x squared plus 9 minus 6x squared plus 2x all over x squared plus 3 squared. So now we have 6x minus 2 over x squared plus 3 times, looks like negative 3x squared plus 2x plus 9 all over the quantity x squared plus 3 squared. If you want to multiply it out, you can, or you can just leave it as the quantity 6x minus 2 times the quantity negative 3x squared plus 2x plus 9 all over x squared plus 3 cubed, because we have 2 here and another one here, so it now becomes cubed. So let's find the equation of the tangent line to the graph of f of x equals 2 sine of x plus cosine of 2x at the point pi 1. So the first thing we need to do is we need to find the derivative, because that's going to help us find slope. So f prime of x, sine goes to cosine, so it's 2 cosine of x. Cosine goes to negative sine, so minus sine of 2x times the derivative of the inside, which is just 2. So then let's plug in our x value. So f prime of pi is 2 cosine of pi minus 2 sine of 2 pi. So cosine of pi is negative 1. Sine of 2 pi is 0. So that goes to 0 over here. 2 times negative 1 is negative 2. Now we have a slope and we have a point. So y minus 1 equals negative 2x minus pi. And you can leave it like that, or you can solve it. So y minus 1 equals negative 2x plus 2 pi. Y equals negative 2x plus 2 pi plus 1. Either one of these equations works. They're the same thing.